Hi, welcome back to my channel. I'm Anando, and today we're going to do questions from the Physics 12 View textbook, Chapter 1.4 Review Problems, Velocity and Acceleration in 2D. I might just do one or two problems and then leave the rest to you guys because it's basically the same concepts, just used in different forms. So I'm going to start off by doing question number 2. So during 4 meters on a lake, a loon moves 25 meters east, 30 degrees north, and then 75 meters east, 45 degrees south. Determine the loon's part A total distance traveled, part B total displacement, part C average speed, and part D average velocity. So we'll start off by doing part A, find the total distance traveled. So you know distance is a scalar quantity, so it doesn't matter what direction it's going in, so you just add the magnitudes. So you know it's 75 meters and you know 25 meters is the other magnitude, so you just add them together and this gives you your distance traveled. Now for total displacement, it's a little bit different compared to the distance traveled because now there's vectors involved, which means there's directions. So because there is directions, opposite directions, you have to add them in a certain way that the directions are in the same direction. I know this kind of makes no sense right now, but like it'll make more sense once I start doing it for you guys. So you already know that the first displacement is 25 meters east, 30 degrees north, which I've drawn here as a diagram, and displacement 2 is 75 meters east, 45 degrees south. So this angle is 45 degrees south, and this is displacement 2. So to solve this problem and to find the displacement, you have to go into components. You have to find the x components and y components of each displacement, and then add them together to get a net displacement. So I'm going to go ahead and find the x component and y components for both the displacements. But before I go on to that, I'm going to talk about how you can find that. So let's take this for example, displacement 1. I've gone ahead and drawn a triangle for it. Let's say this is displacement 1 and it's 30 degrees. So your y component is going to be this and your x component is going to be this. You should remember from a few years back where you did trigonometric ratios, where sine, cosine, and tangent. You guys probably did this. You guys did this in sine, cosine, and tangent. So you know sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So your adjacent side is going to be your x component, your opposite side is going to be your y component. So if you did sine 30, it's going to be opposite over hypotenuse. Your hypotenuse is the total displacement from displacement 1. So opposite over hypotenuse, and then cosine will be adjacent over hypotenuse. So you could use sine 30 equals opposite over hypotenuse or displacement, and then rearrange for the opposite side to get the y component. And then you could do the same thing using cosine, but isolate for the adjacent side. So I'm gonna go ahead and do it, but I've already gone ahead and done this. So displacement 1, x component is 25 times cos 30, which gives you 21.65 meters east. Displacement 2, x component is 75 cos 45, which is 53.033 meters east. Now going on to the y components, displacement 1's y component is 25 times sine 30, which gives you 12.5 meters north since it's going north. And then displacement 2 y component is 75 meters sine 45, which gives you 53.033 meters south. Now to move on and calculate the net displacements, I've gone ahead and done it already set it up for x and y. So 21.65 meters east plus 53.033 meters east, and that gives you 74.683 meters east. Now for the y direction, or the y components, remember before how I said that displacement 1's y component is 12.5 meters north and displacement 2's is 53.033 meters south? Note that they're both in opposite directions. This is going north, this is going south. So to add them, you're going to have to convert them into the same direction. So 12.5 meters north can be rewritten as negative 12.5 meters south. So that's what I've already gone ahead and done. 53.033 meters south plus negative 12.5 meters south. and that gives you 40.533 meters south. So we'll say this is displacement total in the x direction, this is displacement total in the y direction, and this is your total displacement, and this is angle theta. So your displacement total, since this is a right angle triangle, you can just use the Pythagorean theorem. So displacement total squared equals displacement tx squared plus displacement ty squared. So root of 74.683 squared plus 40.533 squared. And that gives you root of 7220.474, which is 84.97, or approximately 85 meters as the displacement. But remember that this is on an angle, so it's not just 85 meters east or 85 meters south. It's on an angle. So to find the angle, you have the opposite side and you have the adjacent side. So to find the angle, you could just do tan. You could use the tan ratios. So tan theta equals displacement ty over displacement tx. So ty is 40.533 and x is 74.683. Do the tan inverse of that. And you end up getting 28 degrees. So the total displacement is 85 meters east, since the guy goes east, and then 28 degrees south, since theta is 28 degrees. So that is how you solve part 2, question 2, part B. So now to find part C, which is the average speed, you take the distance traveled and divide it by the time taken to travel. So you're given the time as 4 minutes, convert that to seconds, do 4 minutes times 60 seconds, and you get 240 seconds. Now speed is distance over time. You're given distance as 100 meters since you already found it, and then time you already have, you plug it in and you get 0.42 meters per second as the speed. Now for velocity, you do almost the same thing, but you have to take the displacement now and divide it by the time. The time is the same, but the displacement is 85 meters east, 28 degrees south, divided by 240 seconds. And that gives you a velocity of 0.354, which is approximately 0.35 meters per second east, 28 degrees south.